Welcome to this channel. Today we're going to cover trigonometry basics made easy. So we're going to cover the easy pre-math tricks that you should not miss. These tricks can be used at any level of mathematics, starting from the pre-math and the graduate mathematics, the graduate mathematics as well. Yeah, because the trigonometry is built upon these fundamentals that we're going to cover today in this lesson, because the whole trigonometry concept is built on the unit circle and the special angles. Then we also cover the aspects of the relationships between the trigonometric functions for these special angles and see how they are related from quadrant 1 up to quadrant 4. Okay, so if you haven't yet subscribed to this channel, please do so. Okay, let's go. So if you can see, by the end of this lesson, we're going to understand how to quickly know or even memorize these values that we have on the table here, so that if you are just taking overnight to say what is the sine of 30 degrees, you just know that's half. What is the tangent of 45 degrees, you just know that it's 1. It will just become part of you. Okay, and then this makes the whole understanding of geometry, in particular trigonometry, become easy. Okay, so that if maybe someone can just ask you often, what is the tangent of 180, then quickly you know that this is 0. But you say what is the tangent of 270, you will quickly know that it's undefined. It's either negative infinity or positive infinity, so it's undefined. Okay, what about tangent of 360? You know that it is 0 very quickly. Okay, but this one is the slide which we'll end with at the bottom. We'll start now breaking this one into parts. Okay, before we go back to breaking into parts, what we'll do, I can just take you through what we'll do up to here, up to the end here. Okay, so we're breaking this into parts. Okay, let's start with before I go down, this stands for quadrant 1, the Q1. So it's quadrant 1, quadrant 2, quadrant 3, and quadrant 4, because there are 4 quadrants here. If you have a unit circle like this one of radius 1, then every point that we have on this circle will have the radius 1. So you can draw a right angle triangle here, and x and y, they will be the ones which have got the 90 degrees between them, and then the angle theta will be between x and 1 always. Okay, between the horizontal axis and the hypotenuse. It's because we are starting from the positive axis here, 0 degrees. It means the point will be here, which will be x will be 0, x will be 1 at this point, and then which is here, x will be 1 and y will be 0. So at this point, this will be the sine or cosine of 0 degrees, which means there will be no triangle now here. The triangle will collapse into a segment, a line segment, just a line. But the moment you start from 1 degrees, 2 degrees, 3 degrees, you go up to 90 degrees, 180 degrees. As you go from left to right, the triangle becomes bigger and bigger until it would become a circle when we reach at 360, because you have moved around the circle as a complete revolution. Okay, so the 0 will be the same point as the, when we got the 0 will be the same point as the 360. Okay, so with the angles in degrees and then angles in radians with the pi here, okay, which is 2 pi radians, which is 360 degrees, half pi radians, which is 90 degrees, and so forth. Pi radians, which is 180 degrees. Okay, so then this is the unit circle, which we've got quadrant 1, which is here, the one which is as well got the positive x-axis and the positive y-axis. Then this is quadrant 1. But when we move anti-clockwise to quadrant 2, then now y is still positive, but now x values are negative here. When we continue to quadrant 3, then both x and y here are negative, because x is on the left hand side of the y-axis, and y also is below the x-axis, the horizontal. So these ones both are negative here. Okay, x and y. Okay, which means both cosine and sine will be negative here. Here, all of them, sine and cosine, will be positive, which means if sine and cosine are positive, then all these things that we have here are positive. Here, it is the sine, and the sine will be positive because the sine is the x, is the y coordinate, the vertical, while this cosine is the horizontal, so the cosine here will be negative. Okay, that's why the tangent also will be negative, and the also it's only the one which is a derivative of the positive one that will remain positive, but the rest will become what, negative. Here both are what, negative, which means the tangent will be positive here in this quadrant 3. Okay, and also its derivative, the cotangent. Here you find that the cosine is the one which will be positive here. Okay, only, but the sine will not be positive, so it means the tangent will be negative as well, because there are different signs. Okay, why are we saying like this? Because this is a unit circle. So being a unit circle of radius 1, it means that the x square plus y square is equal to 1. Okay, and again, if you so that's quadratic, which means it means x square. In this case, x will be cosine square, and then y square will be sine squared, which means the sum of cosine square and one sine square for every angle, whether in degrees or in radians, will be for the all angle in whether degrees or radians will be 1. Okay, okay, this one we're counting in the radians. Okay, but it will be 1 in whichever measurement you're using. Okay, then this one here, the if we take the SOHCAHTOA, so is sine is opposite of hypotenuse. So sine of this angle theta is opposite to y of hypotenuse, y over 1. That's why sine is just y over 1, which is y divided by 1, which is just sine is just y. And cosine of this angle theta, SOHCAHTOA. SOHCAH is cosine adjacent of hypotenuse, so adjacent is x over 1. That's why cosine is just x. So the x coordinate will be the cosine, the y coordinate will be the sine on this point, and the radius will be always 1. That's why it's a unit circle. It means just with radius 1, that's no unit. And then in that case, the tangent will just be the ratio of these y divided, because this x and y, they will not go beyond 1, so they will be just have a magnitude of between 0 and 1, including 0 and including 1. But because of direction, the direction can be positive or negative. They were already explained depending on the quadrants, but the magnitude will be between 0 and 1. Okay, and inclusive. Okay, now the tangent, now if we divide those ratios, the sine divided by the cosine, the sine on the numerator, the y, and then the cosine denominator will be the tangent. And then you see the moment we know sine and cosine, that's all. Then the tangent we just divide sine divided by cosine, and again these three in that order. Cosecant we just take the reciprocal of sine, secant we take the reciprocal of cosine, and then cotangent we take the reciprocal of tangent to find cotangent. So in that order I've put here. So this one would be reciprocal of the top one, and then the second one here of the second one, the third one of the third one. These on top, these three are the fundamental trig functions, whereby these ones are the derived trig functions that depended on the fundamental above by just taking the reciprocal. Alright, so this is the idea about 4 quarters. Now we had here, by the end of the day, we want to see how we can memorize or understand by heart or easily know these ratios for these 16 special angles, because we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that's 16, because 17, the 360 is a completive fraction. So when you see this one of the 0, it will be exactly the same as the 360. So which means they're just 16 special angles. Okay, whereby when we start 360 evolution, when we continue going from 360, if we add 30, so we go to 390, we are coming back to the answer to be the same as this one. Then if we add on 360 45, then the answer will be the same. So what it means is whatever special angle we have here, if we add 360, we'll come at the same point. Not only 360, if we add 360, if we add 720, if we add, in other ways, if we add an integral multiple of 360, when 360 is 2 pi, then we'll get the same point. Okay, so which means we've got 60 degrees here. We can just add 720 to 60 degrees, then the answers of the angle 720 plus 60 will have the same answers as 60. So that's why these build these basic concepts, and then you can know the relationship of every other special angle in the world that is related, is linked to these special angles through these coordinates. Okay, ASTK C. This you can use anything, but in my case I try to use it for me to memorize quickly. I say all students take Coca-Cola. Okay, so all students take Coca-Cola. I can put a hyphen there. All students. So I got all. That is the quadrant number 1, which is this one here. students, all is in quadrant 1 here. Students is in quadrant 2. All is in quadrant 1. Okay, so all is in quadrant 1, and then tech is in quadrant 3. Okay, I wanted to see the relationship between how we obtain the trig functions for 3, quadrant 3, taking from 1. Again here, how we get quadrant 2 in linking to quadrant 1, and here that's how we find for quadrant 1. Okay, and then the first one was for the principal ones. The principal ones are the ones which are on the main axis. The 0 here, which will come back to 360 as well, as I explained. We go anti-clockwise, the 90, and then we have got the 180, and then the 270, 3 pi over 2. So these are the principal ones because they are all axial ones because they stand the right away on the intersection of the circle and the main axis, the principal axis, x and y axis. Okay, on the positive side here, and of x, and on the positive side of y, and then on the negative side of x, and then on the negative side of y. So there are 4 points, but 360 you come back to the same points. That's why I put 5 principal angles. Okay, and then at the end here in quadrant 4, this is quadrant 3, quadrant 4. So I just wanted to change here again, Coca-Cola. Okay, so we are going to see again how quadrant 1 is linked with quadrant 4, how we can get the results from quadrant 1 into quadrant 4. So this will be, and then we summarize here Coca-Cola, which will get the same thing which we have. This is the end of this will be the end of our lesson, which is the same page which we have at the beginning here. Okay, so just wanted to motivate that what we are going to do, we want to see how to understand all this one. Let us go. Okay, so all students take Coca-Cola. Okay, or all students take chemistry, or all students take club, all students take chikwangwa, all students take whatever you can put there, coins. It's up to you, or you can, or chips. So all students take chips. If you like chips, just put something which you like, which starts with C. Okay, yes, I know many people like chips, so all students take chips. Okay, but Coca-Cola is also neutral, so all students take Coca-Cola. Let's just move on. Let's start with the, so if you see these 5 angles, if you see here, these 5 angles are the ones I put in like blue. So you see this one, 90 degrees, and then the 180, and then the 270, and then the other one, which is the 360. So if we take these ones, 1, 2, 3, 4, 5, these are the principal ones, which are very easy, which you can just get from the unit circle straight here. How do we do it? I've already explained here that the x coordinate is cosine and y coordinate is sine. So if we start here, we are on 0, we start from here 0, which will be the same as 360, 2 pi after evaluation. So we can just see we want sine. So if we want sine, I can do like that, so that when I write that is sine, it means when we are here on 0, sine, we are looking at the y coordinate. So sine of 0 degrees is simply 0 here. Now if we come here, sine of 90 degrees, just look at y coordinate, which is 1. We come here, sine of 180 degrees, which is pi, 180 degrees, which is here. Then you'll find that this one here will be simply 0. Or if you come here 270 degrees, only that I didn't label here, you could label here 0, could label here pi over 2, and you label here pi, here 3 pi by 2, here again 2 pi. Okay, so on these points, only I didn't label because it was too confusing. There were too many things, so I just stopped. I didn't just indicate them. Okay, so which means we have got negative 1 for 270. Then we come back 360 to be 0 again. Okay, if we want for cosine, if I take the second one, the second row, that's for cosine. Then for 0, it will be 1 because cosine is x. Cosine is x, so it will be 1. And for 90, it will be the x will be 0. For 180, for 90 will be 0. So it's here. For 180, we come here, cosine will be the x-axis, x coordinate. So will be 1, negative 1. That's why we got negative 1. And then for 270 here, we get the x coordinate, which will be 0 for 270. And then the cosine for 360, we come back here. For 360, it will be the x, which will be 1. Okay. So if you want to find the tangent now, for the tangent, then it is simply y divided by x. or sine divided by cosine. So which means you just divide this on top. 0 divided by 1, which means you are dividing sine, which is 0, divided by cosine, which is 1. So 0 divided by 1, then the answer is 0. But when you go on 90 degrees to find the tangent of 90 degrees, okay, because we're dividing y divided by x, so it will be 1 divided by 0. Then 1 divided by 0, 0 is in the denominator, undefined. Okay, because it will be either positive infinity or negative infinity. Okay, so it is undefined. U is for undefined, which is undefined is very big. It does not exist, in other words. Okay, then if you go on tangent of 180, it will be 0 divided by minus 1. So 0 is on the numerator, minus 1 on the denominator, so it will be 0 again. 270, so y divided by x, which is sine theta, which is minus 1, divided by 0, so it will be undefined again here. So tangent will be undefined at 90 and at 270. Tangent will be undefined here at 90 and at 270. Okay, so if we come here on 360 again back, it will be like 1, which will be again 0, because it will be 0 divided by 1, which is defined, but it is 0. Okay. Alright, so now if we want to find the derived ones, the cosec, sec and cotangent, these ones are easy because we just take the derivatives of these three. So for example, if we want the cosec of 0, you just divide, because cosec is a reciprocal of sine. I've put them in order already. So the top one, the first one, these three derived, the first one is derivative of the top one. So it's better to put them in that order. And then the second one, the cosine, second is derivative of cosine. And the last three, the cotangent, is a derivative of tangent. So it's easy. So just be taking the reciprocal of these line 3 above respectively. So if like here you take reciprocal of 0, is undefined. Reciprocal of 1 is 1 again. Reciprocal of 0, undefined. Reciprocal of 1, 1. Of 0, undefined. Of undefined, 1. Okay, so here what happens, the reciprocal of 0 is undefined because thou shall not divide by 0. Okay, now the reciprocal of undefined, it becomes 0. Of course, it does not mean that an undefined is a real number. It does not exist in an infinite. But the idea is by using limits, it means that undefined is a very, very big number. So whether it's positive or negative, undefined, but it's a very, very big number. When you take a reciprocal of a very, very big number, by limits it approaches to 0. So it's not directly like a reciprocal of an infinity of undefined exists. No. But by limits, it means if the number is very big, the reciprocal approaches to 0. So which is true. So whenever there is a reciprocal of division by when you divide by 1 divided by what, reciprocal of undefined, it becomes 0. Okay, and it's true, it's correct. Okay, in terms of limit wise, using the calculus. Okay, and then we have similarly all of them will do the same thing, which means if you wanted for 180, which means the first one reciprocal will be undefined, 0, 0, but for minus 1 it will be minus 1, and then minus 1 here and 0, the reciprocal will be minus 1, for 0 will be undefined, and then for undefined will be 0. Okay, so here is 0. I think I removed something here, so this one is 0. Okay, let me save. Okay, like that. So you can see that this portion, then we have managed to find all these ones, the blue ones. Let us see now these colors. Let us see now this one, the quadrant 1. How do we know the quadrant 1? Then we move to quadrant 2, then we move to quadrant 3 and quadrant 4. Okay, let's go to quadrant 1. We have done these 5 principal ones. Let us go to quadrant 1. Quadrant 1 meaning the ones which are not on the axis. They are not on here, on these points which intersecting the axis, but there are in quadrant 1, but there are inside here. Okay, and the quadrant 2 will go the ones which are here. Quadrant 3 the ones which are here, and quadrant 4 the ones which are here, but excluding the ones on the axis. These 5. Okay, so these ones on the axis, you can see that all the answers are either 1, 0, either plus or minus 1, 0 or undefined. Okay, so the undefined can also be negative or positive infinity, but we here have just used undefined. But if we are very serious, some of them they could be positive infinity, plus infinity, others would be negative infinity. But all of them have just put a undefined because whichever case yeah. So we have only the plus or minus 1, 0 or infinity. But when we go to this inside now, not on the boundaries of not the principal, but these special ones now. These we call them just special angles. There will be 3, 3, 3, 3, 3, 3. So which is 12. Because here we have 3, 3, 3, 3, which is 12, and then 12 plus these 4, which we had here, 1, 2, 3, 4. That's why we have 16 special angles, because okay, there are 17 if we consider 360, but 360 the concept would have done without 360, because the concept is that all these are special angles which are 16 up to here. Then any integral multiple of 2 pi plus these, it means you are just completing evolutions, they will be coming the same thing. So plus or minus, it means if you go clockwise or anti-clockwise. Minus, it means going going clockwise. Positive, when you start from here, when you go this direction, it's a positive. Okay, but when you go clockwise, it's negative. So whether it's positive or it's negative, as long plus or minus, so it's an integral multiple of 2 pi. Whether it's plus or minus 2 pi. In other words, we say 2n pi, where n is an integer, which n can be 0. If it is 0, it means you are at the same point, which means you are neither moving to the left nor to the right. You are not doing any rotation. That is n is 0. But n2 pi, if you have got n as an integer, so it should not be a decimal point. So if n is plus or minus 1, it means you are moving 360 one revolution clockwise, that is the positive 1. When n is minus 1, it will be minus 2 pi, you are moving anti-clockwise one revolution. If the n is 6, which means you have 12 pi, then if it is positive, it means you make 6 revolutions, so we'll come back to the same point. Whereby if it was negative 12, you make 6 revolutions to come back. So that's why this is very important. When we know the trick of these ones, then you can link with the idea of 2n pi, where n is an integer. Yeah, so we can take any number 0 or plus or minus 1, but an integer whole number, and plus their negatives. Alright, now let us go to these others. Now they will have the fractions. The ratios will become the fractions now. Let us see in quadrant 1. In quadrant 1, we say all of them they are positive. That's why you can see all of them they are positive in quadrant 1. Okay, but we'll see when we go to quadrant 2, we say that sine is positive. Only sine is positive. When we say only sine, we mean when we consider these 3 fundamental ones: sine, tangent, and cosine. So only sine is positive. Here, all 3 are positive. Sine, cosine, tangent, all of them are positive. Okay. Here, only sine is positive of these 3. Here, in quadrant 3, only tangent, t is tangent. Tangent is positive. Only tangent, which means the sine and cosine are negative in quadrant 3. In quadrant 4, only cosine is positive, which means sine and tangent are negative. So here, sine and tangent are negative. Here, tangent is positive, so cosine and the sine are negative. Here, cosine is positive, it means tangent and sine are negative. Here, sine is positive, it means cosine and tangent are negative. Here, all of them, sine, cosine, and tangent are positive. So if we know these 3, then to come here, it means if like here, if all are positive, it means this derivative also all 3 are positive. But here, if only sine was positive, only sine is positive, you can see only sine is positive, these 2 are negative. Okay, only sine is positive, it means when we go down, the one which is the derivative of sine, which is the cosec, will be also positive, but the rest of those others will be negative. So similarly here, because the tangent only is positive, it means its derivative, the cotangent only, will be positive. Similarly here, because the cosine only is positive, the middle one, then the middle one, the second only, will be also positive only. Yeah, that's what happens. Okay, let's move on. So now we're dealing with the quadrant 1, all of them are positive. Okay, so we go, we can go now here, what are here? Yes, so there are 3 angles, special angles, in I've already said, in each of these quadrants. Okay, so there's 30, 45, and 60. Now, these are the basic ones that all the other special angles are linked to these 30, 40, and 50, which is pi by 6, pi over 6, pi over 4 radians, and 3 pi over 2 radians. Okay, so what happens is that we know from the rule of surds, and we can say maybe we know about the rule of 90-degree triangles. I can say the triangles which have got 90 degrees inside, like this one, because always these triangles when we draw all around here, they will have a 90-degree angle. So we can use with this one was first studied by the Pythagoras. So we have the Pythagoras theorem by the Pythagorean. So if we use the Pythagoras and the ratios, we know that for 30 degrees angle in 90 degrees, always the ratios have been proven by using Pythagoras theorem that the opposite side to the angle theta, the opposite side, the ratios of the opposite side to the adjacent side to the hypotenuse are respectively like this: 1 to square root 3 to 2. What it means is this: if you got the angle theta here, okay, so the angle theta can be 30 degrees, 45 degrees, 60 degrees, or any other angle, but we are looking for these 3 because they are special. But even if you have got 15 degrees, this would be like that. what I mean is not ratios, but I mean for 15 degrees it will remain a right angle triangle with x and y like that, and here 1. So for whatever angle we'll have these in black. The x, whatever x we have here, whatever coordinate we get here, we'll have the x coordinate as the x horizontal displacement and y coordinate as the vertical displacement. So these ones, when you square and add them by Pythagoras, always they must make up 1, because this is a unit circle. Okay. Now, knowing that if it is a 30-degree angle, this one, then the ratios must be like this. Then it means for them to fit x square plus y square to make 1, then we do the reverse. Then we can solve, not shown here, but we can do some mathematics here. So after doing it, then x must, because the ratios must be in this ratio. Okay. What it means is, if this hypotenuse was of length 2, this one is 30 degrees, then the ratios of this and this must be root 3 and 1. In other words, in this triangle, like if this is a right angle triangle and with 30 degrees here, then the ratio of these sides must be with this red color. They must be 1, the opposite, to adjacent, which is square 3, to hypotenuse, which is 2. Now to fit a unit circle, to make this one to have a 1, it means we must divide all of them by 2. That's the easy mathematics. So it means for this one to be a 1, it means we divide by the ratios, because these are proportional. Because here in each circle it must be x to y to 1. Okay, if we use OAH, it must be y to x to 1. So it means y to x to 1 will be 1 to root 3 to 2. But now we want to force them to make them to have the hypotenuse 1. It means we divide by the ratios. Okay, I would have shown this one, it's just equating both sides. Okay, so when you divide by the ratios, it means this one, for this to work, it means y, you must divide by its ratio. So it must be just y, the opposite. And then this one, I mean not just divided by its ratio, I mean we must divide by the hypotenuse, because we want to normalize to make the hypotenuse 1. So it means all the sides, all the what ratios, I mean, you must divide, all the sides, I mean, you must divide by what? By the ratio, by 2. Okay, in other words, if these are the ratios, it means if you divide by a same number, if you multiply or divide by the same number, all of them, the ratio does not change. Hello? The concept is that if you divide, if I put here 20, if you multiply by 10, then it will be 20. By 10, it will be 10. By 10, it will be 10 root 3, then it will remain valid. If you can draw a triangle with 10 centimeters or 10 millimeters, and then 10 root 3 millimeters here, draw here 90 degrees, here 30 degrees, it means this will be 60, then this one will be 20. If you measure it will be 20 millimeters or 20 centimeters. That's what we're saying. If you did multiply by root 3, it means this one will be root 3, this one times root 3 will be just 3, then this one will be 2 root 3. If you draw such a triangle, it will work with 90, 30. That's what it means. So it means using these ratios, then there will be a certain proportionality constant, which means when you multiply, this one will be y, this one will be x, and this one will be y. Hello? I think you have understood now. So in that case, it means this one, for it to make a 1, it means this 1 we divide by 2, so which means this hypotenuse, okay, I mean which means because we divided by 2, so and then this one you divide by 2, you divide all of them by 2, which means y will be a half, and x will be root 3 divided by 2. In that case, the hypotenuse, that square, will be 1. I think you have understood what we mean. Yeah. So in that case, it means for this to work and to satisfy this, what we're saying, it means these coordinates must be this. In that case, it means for 30 degrees, sine of 30 degrees, sine is a y, so it means a half. Cosine is an x coordinate. So after we've solved here, we found that the coordinates must be like this to fit this triangle and Pythagoras theorem, and the ratios are out there. So then this one, as we're saying, then the tangent of 30 degrees, it will be the ratio of sine divided by the cosine. So which means the sine, the y, which is half divided by this. What does it mean? It means the 2's will cancel, so it will just be 1 divided by root 3. Or you can rationalize the denominator, so this will just be the same as root 3 divided by 3, whichever. Okay, all these ones which we have here, if you want the denominator here, you can rationalize. When I put root 3 at the bottom, you can rationalize, multiply by root 3 on top and on bottom. So this will be root 3 divided by 3. This one will be 2 root 3 divided by 3. This one will be 2 root 3 again divided by 3. This one is already rationalized denominator. Alright, this one will be root 2 divided by 2. Root 2 divided by 2. So you can rationalize the denominators, there's no problem. Okay. But we can leave them like that also. It's the same thing, okay, as long as you understand. So if you rationalize, if you recall this table, you can rationalize all the denominators. It's fine. Yeah, as I will explain. Okay, now we have done it. So it means sine for 30 degrees, which means we're done. What have we said? This we have said sine must be half, and cosine must be √3/2, and then the tangent must be, we divide this by this, which is also 1/3. Then to find these 3 at the bottom, as already said, we just divide by, we take the reciprocals of the above. So this one takes the reciprocal of this one, it means sine of 30 is half, it means cosecant is 2. Cosecant of this one, it means you just reciprocal, so the numerator and denominator swap, which means you can rationalize, which means it will be 2√3 divided by 3. Okay, over 3. For the cot, you so again reciprocate this one. So take the reciprocal, so it will be on top. That's for cotangent. Yeah, great. So we're done. We've covered for 30 degrees. What about for 45 degrees? Okay, as we've done here for 30 degrees, it means we've also already done for 60 degrees. Okay, I'll show the problem why. If this angle was just 60, then the ratios swap. This 2 remains the 2, but the √3 and the √3 and 1, they will swap. Why? Because it means this angle here was 60. Now, but when we are doing trigonometry, we take the angle at the center. We measure the center here between the x-axis and the line, the hypotenuse joining from the center to this coordinate we have here. So this point is going around the circle. Is going on the circle, so which means the angle is the one measured anti-clockwise, like here. So we're not using this 60, but if we want to go for 60, then we have to reconstruct this, which means the 60 will be somewhere there. If this one was 30, then it will also not allowed to scale, then 30, maybe 60 somewhere there. Okay, then it means it will be bigger, then this one will be 30. If we do that, this one will swap, the hypotenuse will remain the same. What happens here is that √3 will start and then 1 will come here. Because of that, then they will swap. So it means they'll just swap. So what it means is the one which was a half is the one which will come for cosine. The one which was this one for cosine is the one which will come for sine. And then when we divide here, then it will be reciprocal again. So sine of tangent of theta will be reciprocal of tangent of 60. They will just be reciprocal. Okay. While here again, if you do the same thing we are doing, then you take just this divided by this one. You reciprocate. This one again half reciprocate, which is 2. This one reciprocate, which is that one. Okay, and always tan and cot again of 30 and cot of 60, there are reciprocals. Tangent of 30 and tangent of 60, there are also reciprocals, okay, of each other, or inverses of each other. Reciprocals or inverses of each other. This one is tangent 60 and the tangent 30, as well the tangent cotangent 60 and cotangent 30. They will be just they're going to be derived by just what? Why? Because tan is sine over cosine, and cot is the reciprocal of tangent. What it means is cot is cosine over sine. Okay, that's why there is always this relationship of tangent and cotangent, not only for 30 and 60, but for all angles in the world. The tangent and the cot are reciprocals of each other, because one is sine over cosine and the other one is cosine over sine. Okay, all right. So then what about for 45? Okay, so I can just go down on this page what I'm explaining. So this one is for the 60. I'm explaining. This one is for the 61. I can save. Let me save. Okay, let me leave it the way it is. Okay, let me undo. Is it undo? Where am I? I'm here. Undo. Okay, it's fine. Let me remove. Where am I? Here. Let me redo. Okay, like this. Or undo. Okay, it's fine. It's fine. Does not matter. I can leave it like this. Save. I think something was moving, so it's fine because I was trying to fix this. But we can. It's okay. Like that. Yeah, I can leave it like that. Alright, maybe I can just do like that. Okay, it's fine. Okay, that's why I was pulling it up. It's fine, I can leave it like that. Okay, so let me leave it like that. Yeah, it's fine. So now for 45 degrees, what will happen is that the ratio must be 1 to 1 to root 2. Why? Because this must be isosceles. So this, if it's a 90, this is base 45, this will be isosceles base angles. This one also will be 45. So it means these are 1 to 1, and then by Pythagoras theorem, when we square 1 and 1 and add, square and add, then it will be 2. You see, because 1 square would be 1, 1 square would be 1, which will be 2, and then the hypotenuse will be the square root of the sum squares, so which will be square root of 2. So in that case, we want to normalize so that the hypotenuse is 1. So we want to find what is x and y, so that in these ratios, exactly what we were explaining with 30 degrees here. So I know, because we already explained, if we do the same thing, then it means we have to divide this black, the 1, y, and x, we have to divide them by root 2. In this case, it means the hypotenuse will become 1 over root 2, and then the y will become 1 over root 2. See, and then the x again will become 1 over root 2. If we do this over root 2, this over root 2, it means if you use Pythagoras, if you square this one, it will be half. If you square this one, it will be also half. When you square 1 over root 2, when you square this one, it will be half, because it will be 1 squared divided by, it will be half. Okay, and then if you square this one, it will be half. If you add half plus half, it will be 1. If you take this one to 1, it will be 1 again. So the hypotenuse will be 1 automatically. So in that case, it means cosine is x coordinate, y is y coordinate. It means cosine and sine are both 1 over square root 2. And then tangent is just sine divided by cosine, y divided by x, and they are equal, which means it will be 1. That's why we have here for tangent, sine and cosine, they are the same. Okay, and then if you divide by 1, if you divide them, this sine on numerator divided by cosine, you get 1. Which means if you do the inverse, if you then again the cotangent will be 1 again. Okay, similarly, yeah, and but the cosecant and secant, there will be square root 2 square root 2. Okay, because we reciprocate this one. Okay, for 60 I've already explained. So the ratios, instead of having 1 to root 3 to 2, now the ratios will be root 3 to 1 to 2, which means root 3 and 1 are the ones which are swapping here. Okay, root 3 and 1 are the ones which swap. So what it means is for 30 degrees, if you do opposite adjacent to hypotenuse, the root 3 is in the middle. The hypotenuse is always 2. Okay, so the opposite takes a ratio of 1 for 30, whereby for the 60 degrees, the opposite takes a ratio of root 2, the swap. The adjacent takes a 1. But the hypotenuse remains 2. So if you do the same mathematics we're doing to normalize here, you have to divide by 2, so it will be the same thing. So the only difference is that here, x was 3 over root 2. Here, x is the one which will be root 3 over 2. Okay, root 3x over 2. Okay, x here was root 3 over 2. Okay, let us go here. X will be, so if you divide here, sine divided by cosine. So I think here I did not update. Okay, so you must swap. So it means x and y, they have swapped now. This is the one which is for x. Okay, let me just fix it. So I take this one here, then I take this one half. Okay, let me undo. Let me take this one first. Half. Oh, okay. Let me just delete. Okay, y equals. Okay, so I'll take the half. So copy. I'll take the half and put it not here, but here. The half, and I'll take this one, the 3 over 3 over 2, and put it there. Okay, it should have been like this. So which means the x will be half. Y, because we're dividing by 2, so the x1 will divide by 2, yeah, half. And then y, root 3 will divide by 2, so it will be root 3 divided by 2, yeah. So which means the cosine is the x coordinate. Okay, so here I did the correct thing, but I just forgot here. And then the sine will be the y coordinate, correct. So if we divide, then it means, if you divide these two, the denominators will cancel. Okay, so to be simply, because we're dividing sine on numerator, so it will be root 3 divided by 1, which is root 3. Alright, which means cotangent is the one which will be reciprocal, which will be 1 over 2. So it's what I've already explained here. Okay, so which means find that the sine of 90 or 30 was half, but the cosine of 60 is the one which will be half. The sine of 30 was half, but the cosine of 60 is the one which will be half. I think you have explained. Right. Yes, so we have covered all of these ones in quadrant 1, and all of them that are positive. Then the next, we'll finish very soon. So which means we've covered all these ones up to here, and including 180, 270, and 360. Now we want in the student here, the quadrant 2. How do we find these ones? 120, 135, and 115. Okay, they are linked to this. Why? Because this is 30, there is a 90 here. Then the linking is that 90, if you see 30 and 160, 30 is on the left, 60 units. 120 is on the right of 90, 60 units. See, if you see 135 and 45, they are equidistant from 90, or symmetric. in the y-axis, so that this one is 45 on the left or below. Not below, but on the left of the y-axis. It's on the left, whereby the 135 will be 45 on the right. If you go to 60, 60 will be 30 degrees on the right of. Okay, I think I was saying left instead of right. Okay, sorry for that mistake. I'll just do the opposite. So 60 is on the right, which is 30 units. Okay, but what I meant by left, I meant is below in terms of value. Is it below? Okay, that's why I was saying left or right. Okay, I think you understand me. So you can talk in terms of below and above the value, or you can talk in terms of. Okay, what I mean is this. Okay, 150 is compared to what? 30. Okay, and then 45, 135. Whereby 60 and 30. 120 is 30 above, while 60 is 30 above. Okay, I think I will not explain it correctly here. Okay, but you got me. Let me. I've been making mistakes, but let me just explain with the diagram. Okay, yeah, what I'm saying there. So let's go down here. What I'm saying is here. So we want to see how do we get 120 up to this one. So you can see that the 90 is this one. This is the 90, the y-axis. So this one here on the quadrant 1. This is quadrant 1 and this is quadrant 2. Okay, now I want to see how do we relate the quadrant 2 relating to quadrant 1. Okay, so what I'm saying is whenever you have an angle here in quadrant 1, there is a related angle in quadrant 2. How is it? This one, which is 30, which means you see, for example, you see here, it's an example. This one is not standing for anything, maybe it's 30. Okay, okay. Then, or it's 45, like I put in the middle, could be maybe 45, or it does not matter, maybe 60. Okay, maybe 45 is here. Maybe here, and then 30 would have been below here, but it's fine. So if this one was 30 or 45 or 60, then it has got a linked one here. How? By linked, we mean that we'll have an angle here which will have the same magnitudes of x and y. Why? If you can see here, if I can draw a horizontal line here, you will see that it will be equidistant. So that's what I was saying. So this means 30 will be equidistant to this line as the 120. Sorry, this is not 30. For example, this one is in, okay, if this one was 30, okay, then we have been related to 120. Wow, because maybe I've done only one here. If it was low, if it was 30, okay, that's why here I'm just saying 180 minus theta. This is a good way to how to explain it. So it means if you've got 30 here, then the related one you must subtract from 180. So if you've got 30 degrees, then the related one must be 180 minus 30, which must be 150. If you've got 45, the related one must be 180 minus 45, which is 135. This is the best way to how to explain this. So the key is when you have got a quadrant 2, the angle which is related to quadrant 1, you just subtract pi minus theta. I've put here 180 minus theta. I could as well put here pi. Okay, so okay, it's fine. Okay, I can put here pi. Let me put pi. Let me use pi or 180, but it's the same thing. Okay, it's the same thing. We're going to be 180. I think it's fine. Okay, yeah, because I'm seeing I'm wasting time. Okay, so we can leave it. Let me just leave it and do. Yeah, but if you want in radians, we would write there pi minus theta. Okay, but it's the same thing. I'm doing it in degrees. So 180 minus theta. Then it means this one. If it is 60, it means subtract from 180. It will be related to 120. Whereby 45 will be related to 1. In other words, 30 plus 150 should be 180. 45 plus 135 should be 180 if you add, because we are doing the difference. 60 plus 120 should be 180. Now it's when I'm explaining properly. Yeah. So now if this was the case, then these angles which are related by this relationship of 80 minus theta, it means the coordinates x and y, they will be exactly the same, except that all the coordinates in quadrant 1 will be positive, x and y coordinates, all the values, but here all the values of y again will remain b, which is the same, will be positive, but all the values of x here, all the values of x here, because the x on the left of this line, x is 0 here, so x on the left of this one is negative. So all of them will be negative here. That's why here we said all students take, can say all students, that's why here S, that's why here only sine is positive, because sine is the y coordinate, while cosine is the negative. So tangent, when you divide, it will be negative again. So that's why only cosine, only students, only sine, which means only the top line is positive again here. but the rest here will be negative. Okay, but they'll be exactly the same magnitude. Okay, so what have we said here? It means this one, all the magnitude of this one will be related to 150 because they're related by 180 minus theta. What it means is if this is 30, then this will be 150. Okay, if this was so you can see that the ones I've highlighted, the numerical values, we call them the magnitude, the modulus, must be exactly the same. Half, root 3 over 2, 2, root 3, 3. They will be exactly the same in magnitude disregarding the negatives. They will be exactly the same. But now, what about the negatives now? We just know that here students, quadrant 2, all students take chips, all students take Coca-Cola. So here students only are positive, S is only positive, so which means this will be positive, and the remaining, these ones must be negative. And then if we go derived, the one which is responsible of positive sign, which is cosecant, should be also positive, but the rest will be also what? Negatives. So here I can just see here there's a mistake here. This one must be minus. Yeah, like that, minus. I just made a mistake here. I've just seen it now. This must be, is this what? Yes, minus. Okay, I think here I made the mistake a lot. So this must be a minus 2, and this one must be a minus 2. Yeah, correct, because only sign is positive, so it means here again only cosec must be positive. Okay, so save. This mistake I made, it means I've made also in the beginning. Students, which means this one must have, yeah, negative. Again, this one must be negative. This one also must be negative. I just made a mistake, yeah, which means, yeah, but I just here, I just made a mistake here, I just forgot. Okay, so save. Then similarly at the because at the end of the day we'll go up to this one. So it's here, so that should also correct. So it's minus, here is minus, and here is minus, correct. That's the end. Okay, but let us see how the other quadrants. So we have so far what we've done is we've understood this one, the principle of the unit circle. Yes, this unit circle, and then those to get these 5 and principal angles, which are on the points here. And then in quadrant 1, we have seen how 30 degrees, 45, and 60 are found by these triangles. That's for 30, and this one for 45, and this one for 60. And then we have come here in quadrant 2, we have seen how they are rated by a relationship 180 minus theta. So whatever angle you have in quadrant 1, it's not, this is the principle, it's not only working for these special angles. This principle is working for any angle in the world, as long as in quadrant number 1, any angle, if you say 2 degrees, then just subtract from 180, which is 100, and the 100, the sum must be 180. So which means 2 degrees, it means it will be down here. So if I go 2 degrees, then it means the idea why I'm subtracting 180 minus 2, because if I say 2 degrees, then I must subtract here again a 2 degrees, so it will be here. So which means a 2 degrees here will be related to a 2 degrees here, which will be 178. So which means if I take 2 degrees clockwise, anti-clockwise, and 178, which means it's this which is on 2 degrees and the one which is on 178. It means the A and B will remain the same magnitude, which means the x coordinate will remain the same. It will be symmetric. Only that it will have a negative. The vertical displacement will also be the same. That's the idea. This is known as symmetry. Symmetry is a principle of symmetry. They are symmetric. Symmetry in y-axis, except that because you do a symmetry there, it means the x-axis, the y-axis remains exactly the same line above x-axis, but the x-axis is reflected there. So the x values, will have the negatives, all of them. That's why what we're saying is that the answer that you get for sine will remain the same. Which means if you can do on the calculator there, sine of 2 degrees, it will be the same as sine of 178 degrees. But if you do cosine of 2 degrees, it will be the same magnitude as cosine of 178, but now cosine of 178 will have a minus. That's why I was changing the minuses here. Okay, we'll have the minuses here. Okay, so this principle does not only work for only these angles we are doing here. This concept I'm showing you here, it works for any other angle in the world. It's all built on quadrants. Alright, so I think we've understood this for 30, 45. Sorry, I mean, this one I've already done, but I mean, we've understood that for 30, 45, and 60, how they'll be rated. Which means here, maybe to complete, just one before I go to quadrant 3, I said this one, because when you use 180 minus this one, they will be the same as these ones. Okay, except that these ones here now, they will have negatives if it's other than students, if it's other than sine and its derivative. So where there is sine here and where there is its derivative cosec, that's the only way when it will be positive. The rest to be negative. But the numerical values, they must be, the magnitude must be exactly related to the 30. If we take the 45, this one, when you subtract 180, it will be related to 30. Why? Well, when I was saying 90 equal distance, it means the distance from here is 45 units to the left or right. That's what I was explaining last time. Okay, so which means this is 45, this is 45 to the right, and then this one is again 45 to the left. Okay, so it means 45 below and 45 above. Okay, 45 above 90, 135, 45 below 45, whichever. That's why last time I was making mistake. However, you can interpret it. Okay, but now we understood with this diagram. Or just say this sum must be 180. Each one of them must be equal to 180 less the other one. Okay, so like 135 is 180 minus 45. Similarly, 45 is 180 minus 135. If the angles are related by this relationship, the other one, you can get the other one by 180 minus theta. Okay, so if you by taking the difference from 180, it means their cosine and sines are exactly the same, except that the cosine values will take negatives, but the sine will remain positive. I think I've explained that a lot. So if you can see, that's why we've got these values, these columns are related, they're exactly the same magnitude, modulus values, except the signs, as I've said. The sign on a student S, only the sine one, and it's so it's only the sine and the cosine. So it's only, if I can highlight here, it's only the sine and this one. Okay, because I'm shifting something. Let me undo. Okay, where is it? Special 3? No. Oh, no, I've gone. Okay, let me undo. Okay, where is it? Yeah, so I think I just leave it. I think I was doing something. Undo. I was doing something. It's undoing. No, it's not undoing. My goodness. Okay, undo. It's not undoing, it's undoing the other thing. Okay, redo, let me redo all of them. Done. Okay, so I must go outside. Where are we? Here. Let me click here. Let me click outside first. Redo. No. I don't know what mistake I've done here. Okay, so let us just move on. Then because of time, I think maybe I dragged something. Let me try to do like this. So it's not about redoing. Yeah. It was resizing. Okay, alright. Now I think I've explained this is enough. Okay, which means again 60 will be with the 120, because this relationship, when you add them, they must add up to 180. So 60 minus 120, 180 minus 120, 120, which means the values must be exactly the same. Okay, sine 12, 12. I don't know what I did here. That's the mistake I did. Okay, I don't know what I did there. Okay, but it's fine. Hey, I did something illegal. Okay, it's fine, because these ones are the top. That's why it was not doing this one here. I don't know what I've done here. Okay, so this must have been the original. Okay, I will set them back after the class. Okay, it's fine because of time. So, but you understand the principle, the concept. Okay, or if not, I can take them from the above here. I can take from, I think see that these ones up to here. Yeah, so I can take from here to 150. Yeah, no, not this one. Yeah, so this one, best. Yeah, no, I think that's the mistake I made. So it's like that, and then this one, I don't know what I did. So board, I did something. Let me even copy this one so that they're the same and paste there, but I put sine. Alright, sine, remove, sine, remove. I made a fatal error here. Okay, save. I won't repeat this mistake. Okay, let us go on now. We have understood. Now if we go to quadrant 3. In quadrant 3, the relationship is 180 plus theta. So, or theta plus 180. So which means you add 180 plus theta. Maybe many people would prefer to put the 180 the other side. So it's plus pi or 180. Okay. So if you have got whatever in quadrant 3, whenever you have got an angle here, like in quadrant 1, so we'll relate this one with tech. Tech is now all students take. In quadrant 3 is take, and quadrant 4 it will be chips or Coca-Cola. Okay, so, or chemistry or whatever. Now all students take chemistry. Okay, all students take Coca-Cola. Now here what will happen is that it's the same explanation we are doing there, only that one was a reflection in the x-axis, in the y-axis. Now this one is a reflection about the origin. Okay, here it's fine, maybe, but these diagrams, because I was just drawing myself, it's fine, you understand it. I've seen that it's not cutting through the origin, maybe like that. Yeah, like that. Okay, so what will happen is that maybe this one I can push a little bit to the right, like that. Let me leave them. Let me undo. Yeah, the weight is fine. So what we are saying here is when you have got an angle here, for example 30 degrees, again this principle doesn't work only for this 30, 180, this one, it works for all the angles that we can have. So to work for all the angles as well. Yeah. Okay, now let us say 30 degrees here. It means if you just add 180, it means you are going diametrically opposite. We call this one diametrically opposite. This one was, the other one was a reflection. Last time was a reflection to the going to the right hand side. If you remember, the other one was a reflection. This one here. So it was not diametrically opposite, but it was a reflection or a symmetry in the y-axis. So or reflection in the y-axis or a symmetry, whichever. So if you get a point here, you just go equidistant, just there. If you get a point here, maybe 80 degrees. If you count 80 degrees, then it will be compared with 100. So which means 80 degrees is here. Then it means you subtract from. Which means if this is 80, it means this side you must subtract also 80. That's why it's symmetric. So it means this one is 80, then it means this side also must be 80. That's what it means. That's why I'm putting theta. That's what I did explain last time. It means whatever angle you have here, then you subtract from the from the x-axis on this 180 degrees going up. So it means if you move 80, it means this angle now is 100. You see? So it means the sine, cosine of 100 they will be the same, except that the cosine will have a negative, but the sines will be the same of 100 and of 80. That's what we were explaining by this quadrant 2. Okay, so in that case, this is a reflection in the y-axis, whereby here is now we call it a reflection about the origin, or we call it diametrically. It's about the origin, or we call it diametrically opposite. So it means here, if it was 30, you add. Now it means 30 now will not be the same as now. Last time we were subtracting, it was 150 or something like that. Last time 30 was the same as 150. This time you see that 30 will be the same as, because it's this quadrant, it will be the same as, now we will add 180 plus 30, which is 210. So 30 will be the same as 210. So you can see the values are exactly the same at pi over 6 and 7 pi over 6. The sine, cosine, tangent, even the cosecant, secant, and the cotangent, the values will be the same here for 30 and for here for what? For 210, which is the 7 pi over 6. They will be the same as here, except that all students take his only tangent is positive, so which means the line of tangent is positive. You can see, whereby these other two must be negative. It's positive, which means the reciprocal of tangent is cot, which means only cot must also be positive, but these two must be negative. But the values are exactly the same. That's the meaning of directly opposite. Similarly, if you get y, okay, maybe I should put down here. What it means is that y is tangent negative, positive here. The reason is here all are positive, quadrant 1, all students, only sine is positive, cosine is negative. That's why tangent is negative, because the tangent is a ratio of y and x, and if one is positive, one is negative, that's why we got negative here. Here, that's when tangent is positive also, like there. Okay, here all of them are positive. What happens is that all are positive here. Then, apart from here, sine is also positive here. That's students. Tangent is also positive where? Here. And then cosine is also positive where? Here. Why? Here cosine is positive because it's on the right hand side of the what? Y-axis. So cosine here and here, cosine is what? Positive. Here and here, sine is positive. Okay. Why diametrically opposite? That's when tangent will be positive. Why? Because here it means sine and cosine, one is negative, one is positive, so it's negative. Tangent is negative. Here again, sine and cosine are both opposite signs. Here again, they are both opposite signs. But here they are both positive, sine and cosine, and here both sine and cosine are negative. because it's only tangent which will be positive. Why? Well, because they are both negatives. When you divide negative by negative, that's why tangent is also negative, which means also cotangent would be negative. That's the explanation why on take here we get like that. But it will be the very same values we got in what in quadrant 1. Just add 180. If you have an angle in this quadrant, any angle, not only this angle, but if you got any angle here, if you want to find its cosine, its tangent, is whatever, all these 6 things, just subtract 180 to find its related angle there. Okay, so what you do is when you do this, then you know that the for this value now, the angle for this value, okay, if for example let's take 100, let's take maybe 20, I mean 20 degrees, 20 degrees. If this is 20 degrees, just add 180. It means sine of 100 will be sine of 200 will be the same as sine of 20. Okay, this is very true. So it means sine of 200 will be the same as sine of 100, but we do have a negative. So sine of 20, sine of 200 will be negative the sine of what was for 20. Similarly, the cosine, because it's also negative here, cosine of 200 will be the negative of the cosine of 100. Therefore, for the tangent will be positive here, and the tangent of 200, only tangent will be positive. That's what we mean here. Okay. So for this special thing you understood now here. So which means for 30 is related to what? 210. For 45, if you add 180, is related to 225. So they will just be the same, except the as I've said that only tangent will be positive and the chord. Okay, the rest will be negative. Okay, only tangent and the chord will be positive. Only chord and tangent will be positive in the quadrant take. But because sine and the positive are both what? Negative. That's why only tangent and its reciprocal cotangent are positive. But sine, cosecant, and the sec, they will be all negatives. Okay. Similarly, for 60 degrees, it means it will be the same as 240. Why? Because the ratio is you add now. So 60, you add 180, so it will be 240. They will have similar values, except the minus that was offset. On a tangent, cotangent, and on a tangent, we'll have what? We'll have positive. Okay, I think I've made another mistake. I made it before. Let me. Yeah, this mistake. I don't know why I'm making this mistake. Okay, I don't know what I'm doing here when I'm making this mistake, when I'm dragging, because here it has done something again. Okay, but it's not a problem, and undo is not undoing. Okay, but it's fine. So yeah, I can leave it like that because of time. This is the mistake I made there. Okay, it's like maybe I'm pasting cells, I'm copying, but it is not undoing. Why? Let me try. It's not undoing. All right. It's something which cannot be undone, but I'm pasting unknowingly. Okay, so let us go. I have understood which was here. Here 210. I can just take them for tangent. I can just take them down. 210 for tangent. 210 for tangent. So there are these values. Okay, copy them. 210 for tangent. 210 for tangent. See these values. Yeah, so it's supposed to be like this. First. Yeah, so that's what I was trying to say, that it will be positive, positive. Then I don't know what I was doing, then it was changing. Okay, but now I've fitted it back. Alright, then let us go finally to quadrant number 4. So because we've done quadrant number 1, quadrant number 2, which is students, then take quadrant number 3, and the last one is quadrant number 4, which is the Coca-Cola, or the chips, or the chemistry. So all students take Coca-Cola in quadrant 4. Okay, so 360 already said that it will repeat the 0 because revolution after pi 2 pi revolution 1 where n is 1. Okay, but you can have again at 720 like that, at 7,200 whatever, it will be repeating on the same 0. Or any other angle here, if you add 270 to 360 or minus clockwise or right clockwise, you'll be coming back to the same these angles already said. Yeah, lastly let us go to the 4th quadrant. This was the 3rd quadrant. Take. Now the 4th quadrant is Coca-Cola. All students take. So all of them I'm linking with the O, with the 1st quadrant. Why? Because it's easy to understand. So what am I saying here? What I was saying here is that you don't need to memorize the whole list table. What I'm saying here is that you just need to memorize only the O. You just need to memorize this part because you see that it's repeating. If you memorize this one, is the only one you can memorize, which are just, and it's easy to memorize this one. It's easy. You need to memorize about 0, 90, 180, 270, 360. Those 5 ones. This one's a must. So take home. You memorize this table. This one you must memorize all of it. This table, but not the whole of it. Just memorize only this part. Only this part, the fundamental ones, the sine, the 3 only, the sine, cosine, and tangent for these angles, so that you know at this one 0, 90, 180, and 270 and 360. Just the 3 sine, cosine, and tangent. Because the rest you don't have to get troubled. Just do reciprocal of these 3 above. So if you just memorize these are enough, and then for the ones, the special angles, the 3, the one I was carrying like this, just memorize 30, 40 and 45 and 60. If you memorize this, then you must just know the link. How do you link them with what? Quadrant 2. Okay, by finding 180 minus these 3 special angles. Link them there, and you use that method we're doing. Again, in quadrant 3, link the same ones with quadrant 3 by adding 180. While here you subtract it from 180. Okay, and then in quadrant 4, now you link by 360 minus what? 180. Okay, let me minimize a little bit. I mean like this, so that you see it on one page. Okay, I've zoomed out. Okay, like this. Yeah, like that. So in fourth quadrant, quadrant 4, that's all students take Coca-Cola. Okay, in this one now, it's like in quadrant 1. To find in quadrant 1, we use those sides ratios and the perpendicular. We can say the Pythagoras theorem and the like, and those ratios 1 root 3, 2 hypotenuse, and then 1 root 2 isosceles 45. That's how we found for those special here. Okay, and it works for even any other angle which is not even special in that quadrant. Okay, you use the Pythagoras theorem. All of them, they have to follow Pythagoras theorem. And then in quadrant 2, we just reflect these ones, subtract 180 so that you reflect in the quadrant 2. Then all of them, they are linked to those ones, and all the y values, the sine values will not change. Here and here, the sine values will be the same, the related thetas or angles. But the cosine is the one which will be here. The cosines will be negatives, okay, of what we had there, but the same magnitude. Okay, whereby in quadrant 3 we used, in quadrant 2 we used 180 minus theta. In quadrant 3 we used theta plus 180. Okay, so this one is now for quadrant 4. Maybe I should put it here. Only that I was trying to, I can put it here, but it's fine. I was trying to show that. Let me put. I think it's fine when you will get it. I was trying to show that. Okay, let me undo it. Okay, undo again. Okay, I was trying to show. So you see this one, this one from here, from the positive x-axis, we go. This one is theta. Then we go this theta plus, not plus, subtract from 360. What it means is that if this is the theta one that I did label here, it means here below there is the equivalent to theta. So this will be theta. So this, you can see this will be a isosceles triangle. See, this will be a isosceles triangle such that if you've got a theta here, this one here will be 90 minus theta. Again, this one will be a base angle. This again will be 90 minus theta. See, that's what will happen. And this one will be again theta. You see, but in terms of the angles, because we measure them from the positive x-axis and go anti-clockwise, then this angle now will not be positive theta, but it will be minus theta. So in other words, 360 minus theta is the same as minus theta. Okay? What I'm trying to say is that, and it will be just a reflection. So what it means is that, unlike here, reflection here, y did not change, b did not change, but a changed to minus. Here it's the opposite. X will not change now here to be the same a. But y is the one which now will reflect in the y-axis. Now the y which will be negative. So in this case now, it means if we reflect here, then we see that now we'll have all the values of y negative in this quadrant. Okay, so that's why it's only cosine is positive, because cosine does not change. So if we take like this one, for example, 30, then we just have to relate 160 minus theta, which means if this was 30, subtract from 360, which means it will be the same as 360. Which means if the 360, if this one was 30, it means from here to here is 30. It means if we go 30 on the negative, it means the whole of it is 360. So if we go negative, this is 30, and we go minus theta down, so that these are equal angles. This angle here must be same as theta there in magnitude. So it means 30, then we go down 30. It means we'll see that it will have 1, 2, 3, 30. Okay, which is by 360 minus 30. So that's the relationship. So which means they will be the same, half for half. 2, 2. With the 3, I'm disregarding the negative signs. But now how do we know the negative signs? Cosine never changes. So which means the line of cosine is the same positive as it was. And then the derivative of cosine, which will be again secant, it will be the same. This one will be the same. But the rest will be negative. These 2. And again here, on the derived ones, these 2 will be negative. Although, yeah, that's all. If we go to 45 degrees, then subtract from, which means 45 degrees going up, we go minus 45 degrees down, which means if you go the clockwise, because we measure the angle clockwise, anti-clockwise, which means 360, because we are going negative 45, so it will be at what? 315. See? That's why all the values that we see here, they will be the same exactly as the values there, except that all students take Coca-Cola. Except that here only cosine is positive, only the mid one are positive. This and this are negative. Only the mid one is positive. That is for the fundamental ones, sine, cosine, tangent. Then when we go to the derived, the one which is derived from cosine, the mid one, which is the secant, will also be positive, like Coca-Cola. Okay, but the rest will be negative. But exactly the very same values we are seeing here, the very same values we are seeing here. Similarly, if we go to 60 degrees. If we go to 60 degrees, it means it will be 60 going up, then 60 going down minus, which means we will be on 300 when we go anti-clockwise. So it means we move 300, so that will go to the 60 equivalent to minus 60. Okay, so it will be the same as the 300. You can see that they're the same for sine, cosine, and tangent of 60 will be the same as associated angle in the fourth quadrant. Okay, which is 300 by 360 minus theta. In the same way, only cosine and secant will be negative. Yeah, ladies and gentlemen, this is very interesting. So by the end of the day, we summarize once again what we started with in one page. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, and then all students take Coca-Cola, all students take chips, all students take chemistry, all students take caterpillar, all students take whatever you can put here as C. Okay, but this one should be all students take. Okay, so for me, it's all students take Coca-Cola. Alright. So then we have the degrees and in radians. So okay, this one is not difficult here. The radians, what you do here is like maybe some people are having problems with the radians here. So 30 degrees, the radian, you just divide by 180. Okay? So which means the radian here, it means if you divide by 180, you find that it's what? It is 6. 30 into 180 is 6 times. You see, that's why this is just 1 pi over 6. So what happens is that if you take this one 1 pi over 6, then this will be 2 pi over 6. Okay, this is 1 pi over 6, then this will be 2 pi over 6. So 2 pi over 6, that's why it is the 2 cancels, well, that's why it's pi over 3. Then this will be 3 pi over 6. That's why it is 3 and 6, that's why it's pi over 2. Then we jump, not jump, this will be, this was 1 pi over 6, 2 pi over 6, 3 pi over 6, then on 120, 4 pi over 6. So you can just divide, that's 2 pi over 3, 4 pi over 6, then we jump, then it's 5 pi over 6, you see, then we jump, then not we jump, these ones we don't jump, the ones in blue. Okay, so that's the rule. So we start with 0, we don't jump. This one is 0 pi over 6, or 0 pi over 4. I mean 0 pi over 6, yes, 0 pi over 6, or 0 pi over 4, or I should say over 8. Okay, so 0 pi over 4, yeah, not over 8, not over 8, but over 4. So this is 0 pi over 4. This is the quarters. When we say pi over 4 is 1 quarter, 45 degrees. is 1/4 of a circle. So pi over 4 is 1/4, whereby 30 over 60 is a 1/6. Okay, what I mean is 1 over 4 is like so like 1/4. 1 over 6, this is the one which is 30. 1/4 will mean 1/4 of 360, because the revolution is 360. So 45 is 1/4 of 360. That's the meaning of 1/4. While by 30 is 1/6 of 360. Okay, so that's why the 0 here, this point at 0 here, this point at 0, this point at 90, at 180, at 270, and 360. It works both, whether you use pi over 6 or you use pi over 4. Let us start with pi over 6. It means this one is at 0, pi over 6. This is at 1, pi over 6. Then we jump. This is at 2 pi over 6. Then this one we don't jump, is at 3 pi over 6. Then this one is at 4 pi over 6. Then we jump. This is at 5 pi over 6. Then this was 5 pi over 6. Then this is 6 pi over 6. That's why I say pi. The 6 cancel. This is 7 pi over 6. Then we jump. This is 8 pi over 6. That's why it's 4 pi over 3. Then this, we don't jump. This was 8 pi. Then this is 9 pi over 6. So 9 pi over 6 will be 3 over 2. 9 pi over 6. Then this will be 10 pi over 6. Then we jump. Okay, this will be 11 pi over 6. Then this we don't jump, will be 12 pi over 6. Hello? If we want to use now these remaining angles, other special angles, because these ones, if you remember the way we're finding them, we're using the 30 and the 60. That's why I was jumping the 40, the ones related to 45. So the ones related to 45, the ones which are in the middle. When you start from this one, you say 0 over 4, 0 pi over 4. Okay, then we go to this one in the middle, which will be 1 pi over 4. Then this you can't jump, it will be 2 pi over 4. Then we go the one in the middle, it will be 3 pi over 4. Then this you can't jump, it will be 4 pi over 4. Then we go in the middle, 5 pi over 4. Then this you can't jump, that was 4 pi over 4. Then 5 pi. Okay, so this was 5 pi over 4, sorry, then 6 pi over 4. Okay, this was 4 pi over 4, which is pi. 5 pi over 4, then this is 6 pi over 4. Okay, you can't jump. Then 6 pi over 4, then you go to the middle, 7 pi over 4. Then you jump this one, 8 pi over 4. Hello? So we've explained how we get for 30 and for 45 and for 60. And then how we relate to this quadrant 2, quadrant 3, how we relate this quadrant 2 that are associated with quadrant 1. This quadrant 3 that are associated with quadrant 1. This quadrant 4 that are associated with quadrant 1. How the quadrant 1 all are positive. The quadrant 2 only student sign, only sign, which means and it's the derivative, which is the cosec, will be positive. And take in 3 only tangent, and its derivative cotangent will be positive. In 4, only Coca-Cola, which is cosine, and its derivative, which is the sec, will be positive. The rest will be negatives. And then these ones at 0, 90, 180, 260, 360, these ones we found them already by using at the beginning step, whereby we just a unit circle and just get on the coordinates where they intersect the x and y axis. Okay, what is the rule how we relate these ones here? We relate them by saying these angles which are here in the second quadrant, you must subtract from 180. So in that case, the 30 will be the same as 150. The 45, the middle will be the same as the middle. The 60 will be the same as 120. It's like the ones which is the distance from 90 degrees, because when we do that, so these will be the same. 45 will be the same as 135, and 30 will be the same as 150. So the near the 45 will be the same, the middle ones will be the same, and the far ones will be the same by using 180 minus theta. While by here in quadrant 3, it's not like that. Here you see we're adding theta. Using quadrant 3 was diametrically opposite. This was the reflection in y-axis. It's diametrically opposite. Now we're going to quadrant 1 and quadrant 3. It's opposite there, like a diameter. So diagonal. So in that case, it means now because we're adding theta, it means they're in the same order. So that 30 you add 180, it will be the same as the first one, 110. 45 you add 180, it will be the same as 225 in that order. 60 you add 180, it will be the same as 240. So which means the first one will be the same as the first one, 210. The second one, the middle, will be the same as the middle one. The last one will be the same as the last one. In all these comparisons, the middle one remains the same. What I mean is when you are relating this the quarter 2 and 1, the middle 45 will be the same as the middle 135. Only that the 30 and the 60 they will swap. The 30 will compare with the 150, the 60 with 120. Well, when you come here, the 45 will be with the middle as usual, but until you don't swap, the 30 will be the same as 210, this will be the same as 240 because you're adding 180. But when you go in the last column, because this one is now reflection in the y-axis. So this one is a reflection in the y-axis, therefore that's why we will see that the 45 will be the same as the middle one as well. But now, because we're subtracting 180, then the 30 will be the same as the 300 and the 60 now. See, they will swap. And then the 60 will be the same as the 300 because you're subtracting from 360. So the 30 will relate to 360 to add up to 330 to add up to 360. The 45 will relate with the mid one without changing. So always the 45 relates with the mid one, 135, and relates with the 225, and relates with the 315. But the 30 in this quadrant, the 30 relates with the 150. And the opposite 60 with 120. Whereby here the 30 with the 210, the 60 with the 120. While when we come here, they do also the opposite, the 30 with the 360 and the 60 with the 300. Okay, and the signs, as we've said, all are positive here. On a S, which means sine, which means with equal sec, that are positive here. And again here on a tangent, which means with cot, are positive here in this quadrant. While here on the cosine and its sec is positive, but the very same values that we are seeing in the quadrant of first quadrant, the values will never change. It's except the way we've said. Hello, if you like, click subscribe, click like, share, and comment. So this is the end of my first class in mathematics. Of course, I've done this one at the level of pre-maths, but I cover all levels, the pre-maths and all the mathematics courses in undergraduate, as well as the postgraduates, the masters, the PhD. Yeah, so I'll be bringing the mathematics at all levels, in linear algebra, abstract algebra, real analysis, functional analysis, topology. Yeah, so linear optimization, calculus, differential equations. Yeah, so we need to hear from you guys. You can ask me any topic in mathematics at any level. I'll be able to present a tutorial. Okay, from pre-mathematics at high school, at college, university, masters, PhD, whatever. Yeah.